the suffocating stillness of ancient stone chambers, where torches burned oxygen faster than men could breathe. Prehistoric builders achieved something that should have been impossible. They built rooms that never choked, holes that stayed cool even in heat that melted metal, and tombs sealed for thousands of years that somehow never grew stale. No windows, no vents, no electricity, yet the air inside moved pure, breathable, alive for centuries. Scientists called it coincidence, but new discoveries buried deep beneath layers of stone are proving something extraordinary. Our ancestors didn't just build walls, they built living structures that breathed on their own. Imagine stepping into a prehistoric tomba-sealed stone chamber with no cracks, no openings, no shafts. You expect suffocation, stale air, lifeless silence. Instead, your torch burns steady. The air feels fresh, almost cool. That's what stunned archaeologists in sites from Egypt to Anatolia, across continents. Ancient chambers, thousands of years old, showed signs of active airflow without any modern system to explain it. A team from the University of Copenhagen excavated the Ain Ghazal structures in Jordan. They noticed something bizarre. The rooms remained ventilated despite being fully enclosed. Even with modern monitors, oxygen levels stayed consistent for hours. Dr. Elisa Werner, an archaeologist studying ancient construction, it was like the buildings were breathing. We sealed every visible opening, but air still circulated. At first. It seemed impossible, but it wasn't magic. It was science, hidden beneath stone, 10,000 years before electricity. The secret lay not above, but below. Excavations at Cataluyuk, one of the world's earliest cities, revealed an overlooked pattern. Each mud-brick home was connected by subtle layers of subfloor cabithis, tiny spaces between foundation stones, designed not for structure but for air movement. Thermal imaging showed temperature differences across these layers, creating natural convection currents. As daytime heat warmed the upper layers, air expanded and pushed upward through minute cracks and plaster joints. Cooler air was drawn in from shaded areas near the base, circulating oxygen naturally without any vents. Modern engineers call this passive convection ventilation. Prehistoric builders understood it intuitively. Similar systems were discovered in the Maltese Hypogeum, a Neolithic underground temple carved from limestone around 4000 BCE. Despite being sealed underground for millennia, its chambers remained perfectly breathable. Acoustic resonance studies revealed airflow patterns that pulsed through the temple's corridors in rhythm with human movement and sound, suggesting that these ancient engineers used sound and vibration to stimulate air circulation through microchannels carved into stone. That's not just architecture. That's environmental engineering, 6,000 years before the first blueprint. But how did air move through walls that looked solid? That's where the true genius emerges. Recent microanalysis from the Göbekli Tepe excavation revealed that many prehistoric builders selected porous stone, deliberately limestone, sandstone. Tough, not just because it was easy to carve, but because its cellular structure absorbed and released air at microscopic scale. These stones contain tiny channels that react to changes in heat and humidity. When sunlight warmed outer walls during the day, the stone expanded slightly, pushing trapped air inward. At night, as temperatures dropped, it contracted, pulling in fresh air through the foundation. This created a bidirectional breathing cycle. The structure inhaled and exhaled in tune with the earth. Modern materials scientists at Kyoto University recreated this process using synthetic stone blocks and recorded measurable oxygen flow through sealed chambers purely from daily thermal expansion. One researcher described it as a building-sized lung made of rock. Prehistoric builders didn't stop there. They engineered surfaces to amplify this phenomenon, using plaster infused with ash and crushed shell materials that absorbed humidity and released cool moisture back into the air, forming a natural air conditioning layer over breathable stone. To them, architecture wasn't inert, it was alive. If the materials breathed, the design guided the breath. From the beehive tombs of Mycenae to the stone towers of Sumer, a recurring geometry emerges: curved domes, narrow necks, spiral corridors. These weren't merely aesthetic choices, created pressure differentials that powered airflow. When wind struck a rounded roof, it split, accelerating along the sides and creating low-pressure zones that drew air upward through interior shafts. This principle, rediscovered in the 20th century as the Venturi effect, was already being used 6,000 years ago. Archaeologists at the Sassi, di Matera cave dwellings in Italy found corridors carved at precise angles to align with the prevailing seasonal winds. The effect was measurable. Airflow increased by up to 40% when wind hit at the designed angle, the same principle powered Persian wind towers centuries later. But its roots stretch back to the Stone Age. And then there's the mystery of spiral vents. In certain megalithic chambers, circular carvings etched near ceilings aren't decorative. Acoustic mapping revealed that airflow passing through these spiral spins, creating microvortex currents that evenly distribute oxygen. It's the earliest known example of air conditioning through geometry, and it worked perfectly enough for sealed tombs to remain breathable for millennia. Modern architects speak of smart buildings, systems that respond to temperature, humidity, and human presence. But prehistoric builders achieved that without sensors, motors, or power. They observed the landscape. They studied heat, shadow, and wind, not through instruments, but through generations of lived experience. Their cities were built like ecosystems. Each wall, stone, and passage contributed to a balanced environment, breathing, cooling, and cleansing the air. In Turkey's Derinkuyu underground city, ventilation shafts stretch nearly 60 meters deep, yet no two are identical. Each follows a slightly curved trajectory, aligning with different wind pressures at the surface. The result? Even in chambers housing 20,000 people, oxygen levels remained stable for months. When archaeologists simulated a full population inside, airflow still circulated naturally, a feat no modern ventilation system could replicate without electricity or fans. One engineer described it best. These weren't just shelters. They were lungs, designed for survival. And perhaps that's the lesson buried in the stone. We build today for convenience. They built for resilience. Their designs worked with nature, not against it. They didn't need windows or wires because they had something far greater, an understanding of the planet's own breathing. Think about this. Right now, the room you're sitting in would become unlivable if the power failed. No airflow, no cooling, no comfort. But thousands of years ago, humans built chambers of stone that stayed fresh forever. They didn't fight the environment. They listened to it. They built walls that breathed, floors that whispered cool air, and ceilings that sang with the wind. We call it ancient architecture, but maybe it was something far more advanced: living engineering, guided by survival, refined by time, and proven by the fact that we're still here to study it. Because when the air stops moving, civilization stops breathing, and our ancestors never forgot how to breathe with the earth itself. If this changed how you see ancient engineering, hit that like button and also subscribe this channel for more rediscovered genius. And tell me in the comments, what other mysteries should we uncover next?